Today we will discuss about the laws of chemical combinations. So laws of chemical combination, it is made by we know usually the L. Lavoisier, Antony Laurent Lavoisier. So it has a perfect definition, that is by studying the result of quantitative measurement of many reactions. It was observed that whenever substances react, the reaction of substances, they follow some certain laws. These laws are called the laws of chemical combination. So this is known as laws of chemical combination. So we know the laws of chemical combination in our book. There will be given in your NCERT book two laws of chemical combination. That number one is conservation of mass and number two is multiple proportion. And constant proportion also some books gives. But usually we say there are five laws of chemical combination. Number one, conservation of mass. Number two, laws of constant proportion or definite proportion. Number three is the laws of multiple proportion. Number four and number five. These laws are will be in class 11. Okay, you're in class 11. So this is number four is Gay-Lucas laws. Number five is Avogadro's hypothesis. So these three laws we will read in class 9, not these 4 and number 5. So usually we have to start laws of conservation of mass, which is important for us in our class 9. So let's start. So we know in our initiative it is written that according to L. Lavoisier, the mass cannot be created, cannot be destroyed. The mass we cannot it neither be created nor be destroyed. So it means what? This mass we cannot create. It will not be created in our universe or whatever. So this mass will be remain in our universe. It will not be destroyed, or we know it may changes its form into something that is not desired. So such as it will change something like heat energy, it can be in light energy, in any. And this statement is somewhat different. This statement is we know that total reaction the total reaction of a chemical of two chemicals will be equal to the products after the reaction. It is okay, it is after the reaction and it is before the reaction. So after the reaction and before the reaction, their mass will be remain same. The mass, suppose in here it was 1 kg, so after the reaction it will be also 1 kg. Understood? Example, I will give you very easy example. In here one example we have that the complete burning of 4.09 gram of carbon in oxygen produces 15.00 gram of carbon dioxide. The product and how many grams is oxygen. So it's very easy. We know what carbon dioxide, C plus O2, it will convert into CO2. Carbon it is given that 4.09 gram, it is not given, and it is given 15.00 gram. Simply we will take it x, or no need to take x, O2 kept in here, and in here CO2 minus C, that means what, 15 minus 4.09. O2's answer will come 10.91 gram. This is O2. So if you will add this 10.91 plus, that is what, 4.09, the answer will come 10, 10, 5, 5. The answer will come 15 gram. Thus it follows the laws of conservation of mass. Very easy example it was, very easy example. Number two, that is we know constant proportion. It is also very important term in our NCERT book that has been given. Its definition is, in a given chemical compound the elements are always combined in the same proportion of mass. That means what, the proportion will be same by mass. The mass number will be same, no matter no matter from which source it has been obtained. I am giving you an example, it will be clear for everyone. Like someone, I have taken H2O, that means water, from the tap. Then you took water from the gutter, and another boy took water from the sea. So why these are in water form? Why these are in water form? Because the mass, its ratio by mass was in 1:8, 1:8, 1:8. I have told no matter from which source it has been obtained. No matter, it can be tap water, it can be gutter water, it can be sea. It should be 1:8. If it will be 2:8, then it will not be water. If it will be 3:8, no, it is not water. We know 3:8 is what? CO2. Very good. So I think you have understood the example. So in here we have a question, that is 5.18 gram of copper metal is first converted to copper nitrate and subsequently to 6.45 gram CuO. CuO, it means what? Copper oxide. So in another experiment, 1.10 gram copper gave 1.37 gram CuO, copper oxide, on combustion. So that the above data verify the law of definite proportion. We have to show what? This data is in our definite proportion, means constant or not. So in here, mass of what? Mass of oxygen in first observation, we can easily see that 6.45, 6.45, and another one is what? 5.18, 5.18. The remaining portion will be 1.27 gram. Okay, so next one, a percentage of oxygen in CuO. Let's do percentage of oxygen in Cu and O. Let's do it. Come, 1.276.45 into 100 if we will do, then we will get 19.68%. This 1.276.45, okay, 45 this is. Next one, if we will do in here, that mass of oxygen in second observation. In second observation, what we got in here? Observation we got 1.37 minus 1.10. Very good. What is the remaining? Gram. Then percentage of oxygen in CuO. Let's do percentage. So it's will come 19.7%. So it given us 19.7%. So we got in here 19.7% one, and another percentage we got in here 19.68%. Very good. So in here we can able to see one is 19.68% oxygen in first observation, percent of oxygen in first observation, and another we got in here 19.7% of oxygen in second observation. Thus we can easily say that this follows the laws of constant proportion. Now you will say, sir, why somewhat different is there? This is point, no matter it is the 19, these are same. So approximately we got in here 19 and 19 gram. So 19 gram oxygen in the first, 19 gram oxygen at the second observation. First and second, these are same, so we can say easily that it follows laws of constant proportion or definite proportion. Another one is left, that is laws of multiple proportion. Okay, multiple proportion. This laws is what I am saying. This laws is formed by John Dalton. We know that it is formulated by John Dalton. So this laws states that according to law of multiple proportion, elements can combine in different ways to form different substance whose mass ratios are a small whole number multiplies of each other. Suppose I am taking an example in here. that I am taking example in here water, that means H2O. H2O one I have taken, and one is hydrogen H2O2 hydrogen peroxide. So in here if I will do the by mass, in here H2 in here H is 2, so 2 is to 16, in here what 2 is to 32. Now in here we know that 1 is to 8 it will come, and in here it will come, what 1 is to 16. Very good. Now just see in here 1 1, this is same, so in here what it bears a small whole number ratio. So thus what it follows laws of multiple proportion. The C 16 and 8, so it also bears a small whole number ratio 1 is to 2. That means in here another one is given, that we know a definition is there in our initiality, that when two elements react with each other to form two or more than two compounds, it form one H2O and another is H2O2, hydrogen, you must say water, and hydrogen peroxide. So two elements it formed compounds, it can be more, like nitrogen if I will take, it can form NO, N2O, NO2, N2O2, many things. So two compounds it formed, or more than also two compound, the masses of one of the element which combines with fixed mass of the other, fixed mass 1 1 of the other, okay, and bear a small whole number ratio to one another. This one and this one will bear a small whole number ratio like 1 is to 2, somewhat like a small whole number ratio will be there. Understood? This is so a math problem we have. So okay, let's see a math. In here we have that two element A and B form two different compounds, like two different compounds. So in the first compound 1 gram of A is combined with 1.44 gram of B. In here we will write at the first given is A and B are two chemicals. Okay sir, बहुत बढ़िया. Next on with 1.44 gram of B. So in the second compound 0.15 gram of A is combined with 0.65 gram of B. So that how this data illustrates the laws of chemical proportion. So we know 1 is to 1 gram of A has combined with 1.44, okay, 1.44 gram of B. This is compound number 1. This was like compound number, this is 1, compound number 1, sorry. This is 1 gram of A has combined with 1.44 gram of B. Now compound number 2 is what? Compound number 2 says us 0.15 gram A has combined with what? Has combined 0.65 gram of B, okay. Therefore we can say in here that 1 gram of A has combined with, so 1 gram of A has combined with simple unitary method we have to apply, very easy. This is 65 by 0.15 into 1. So its answer will come somewhat, if I will just say 65 and if I will do like 65 and 15, like, so its answer properly I got it 4.33 gram of B. This is our answer, 4.33 gram of B. So in here what happened, just in here happened that different weights of B in combination with a fixed weight of A stand in the ratio of, we can able to see in here, 1.44 gram is to 4.33 gram. This is our ratio. Easily we can say this ratio will be 1:3. This is the ratio our, so which is a simple integral ratio, and this data illustrate us that laws of multiple proportion. So it follow laws of multiple proportion. Okay, so that's how we finished our class 9, these 3 laws. So these are the laws. And in class 9 these three laws are very important, not like Gay-Lussac laws and Avogadro's hypothesis. This will be in class 11, so don't worry about it. If you want those videos, then I will make surely. So thank you and bye.